Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, path sum. So the problem says we get a root of a binary tree, and we get an integer target sum, and we want to return true if the tree has a path from root to leaf, such that adding all the values in that path equal the value target sum. And yeah, of course, the definition of a leaf is just a node that doesn't have any children, right? So for example, with this tree, the target sum is 22. If we take this path here, we will get that sum. And so we return true. For the second example, the target sum is 5. There is no path that will give us that. 1 plus 3 is 4. 1 plus 2 is 3. So we can do that. With this one also an empty tree and target sum is 0. This is a good edge case to think about here, because absence doesn't mean 0, right? For it to be equal to target sum equal to 0, we need to have a node that is equal to 0, or even a path that will be equal to 0. So for example, minus 1, minus 1, minus 1, 1, for example, right? But this one is should return false because there is no node that is equal to 0, right? Yeah, so that's the idea here. So should be straightforward solution to just use DFS and just go along a path and keep track of the sum. And if we reach target sum, yeah, we should return true pretty much. So very straightforward solution we can do here. So let's get started. So the first thing we need to do is to do DFS, and we need to pass the node and the sum we have so far, right, of the path, or we can call it like path. And then let's call it path sum, that would be better. And now we need to call it with DFS, initially with the root and with the value 0, and we want to return whatever that returns, right? Now, how do we detect a leaf node? That's where we know we need to stop. So a leaf node doesn't have a left child and doesn't have a right child, right? And well, the condition we are looking for is that the path is equal to target sum. So we need to make sure that this path, and of course we need to add the current node, is equal to the target sum, right? So this would mean that the path all the way from the root, because we started the call from the root, to this current node, which is a leaf node because it doesn't have a left or a right child, and we check that that sum is equal to the desired target sum, right? If this is the case, we know that we need to return true, right? The other base case we have is what if we reach, let's say we had a node that has only a right child, and we went to the right child because this condition was not satisfied, or maybe we reach a leaf node but this condition was not satisfied. Then we will go to the next node, which would be none, and in that case that means we went through this condition but it wasn't true, it was false, and so we need to return false. Okay. And then here the recursion, well, we need to do two things. We need to iterate on the left side of the tree, so that would be node left, and we need to pass what should the path sum change by. Well, we should add the value of the current node, so we do that. This is basically, let's say when we are at this node, when we are, for example, at this node, right, we want to go left, and so we want to add the current sum would be 5 because we already added only this node, and so we need to add 4 and then go here, so we go here with 9, right? So that's why we pass here path sum plus node val. In this case, for example, when we are at 11, we go right, but then it would be that not node because the node would be none. This would be true, and so we'll return false. But otherwise, we would need either, for example, in this case, we'll need to iterate on this subtree, or for example, in this case, we'll need to iterate on this subtree, right? And so we need to also do DFS here on the right side. So here, or DFS on node.right. And we pass the same thing as the left side. And we are doing node or here because we only care about true. So if the left subtree or the right subtree if in any of them we found the path that equals to this target sum, then we should return true. That's why we do an OR here, and so that's what we return at the end, and that should be pretty much it. So let's run this, and let's run on more examples, especially like some examples like one node tree, for example. Okay, so that looks good. Let's submit. Okay, so that passes test cases. Now, in terms of time complexity, this is this will traverse all the way to the height of the tree, right? So you can think of it as either O of the number of nodes in the tree, or like concretely the height of the tree. And in terms of space, we are just using this recursion here. And that's like just using like a stack internally. So it's O of H space as well. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.